Yeah, drop. Hey, huh.
Yo, what's up guys, this is 𝗪𝗘𝗟𝗟𝗟 and today we're playing the REV challenges from 𝗪𝗪𝗟𝗟𝗪 2025. So let's go, we start with echoing gate. It's right here, we download the files. I have already downloaded them, so let's go here, echoing gate and unzip. Okay, cd here and we have this file. Whatever, 𝗪𝗪𝗟𝗟𝗪. Okay, and we get nothing. Let's take a look. Strings, echoing gate, and let's grep for 𝗪𝗪𝗟𝗟𝗟𝗪. Nothing. Let's run ltrace. And so that was a simple ltrace challenge. We see that it compares our input with HTBOO right here. So this was actually the first flag. And let's go with the second one. Graphical Talisman keeper. We unzip it, cd here, and we run the challenge. So we see that, okay, so this actually takes our input right here and probably does some stuff. Again, let's go strings, grep for 𝗪𝗪𝗟𝗪𝗪𝗪. Nothing, ltrace. And as we can see, this was also an ltrace challenge. I think this was the unintended way, but as we can see, if we scroll up a bit, we can actually see the flag HTB, the graphical talisman keep. This is a whole flag. Probably not. Okay, best we can do right now is the graphical talisman keep. I don't see better. Okay, let's try another way, probably the intended one. So we go GDB. Okay. Let's also run the challenge right here. Okay, so the challenge is right here, this process ID. So if we attach this, not attach process, okay, you may also find this problem. So we go right here. We need sudo, so sudo sublime this. It asks for your password. Go here and instead of 1, you do 0. Save that. And again, GDB. So if we attach process right here, okay, cool. We are at this point. Let's continue. So we have A. We enter that. Okay. And if I cut this, so right now if I probably search for the HTB, it will probably pop this up somewhere. But I don't remember, is it search dusty bytes? That Python. So if I do text, let's do bytes. Oh, org. Don't need to. No, I don't want to search hex value. So if I do hex, okay, HTB. Okay, so if I search for these bytes, like something this 4 and 42. Okay, cool. Let's run it again. DB. Go here. Attach 23108. Okay, if I search right now, oh, 6. Okay, I need -x because it actually x. Okay, we still see nothing right here. Continue a bit. Finish. Search again. Break. Nothing. Time to enter. Break it before we that. Get enough. I enter it. Finally. So after we enter the wrong password, and right here on the heap we see that had allocated the flag, and it's the graphical talisman keeper on you right here. So this is actually the flag, and I think this was the intent to do it. Okay, so we do that, and let's proceed with the memory tinker. Let's we go back in memory tinker, unzip it, cd, and we run it. Whisper, wet hands, whatever arrow there. Okay, the pattern is wrong. Strings here. Grab HTB, nothing. Trace. This is, and we see nothing. Okay. Okay, so I think it's time we open it in Decompiler. I'll go with Binary Ninja. Let's go here. We go to main. And let's see what we have. Okay. Yes, if get, so it reads in this buffer. Our buffer probably. And that's a new line. Checks if racks is long. Okay. Starts putting tag. Oh, my dog. Oh, so this is a counter. And right here it actually takes our input, which has to be this long, and it XORs it with 0x37. Takes these bytes and XORs them with 0x37, and if so, it does a flag. So what we have to do is actually take these bytes, 𝗪𝗪𝗪𝗪. So this is the encrypted flag, let's say, bytes for I print, and what we're gonna do is take I, XOR it with 0x37, and I need the character, that. Hopefully, Python Pepe. Okay, HTB reverse the bell, 13. Yes, this might be the flag. Okay, so that was a practice round right here. Let's move on now to the actual competition. We have Rusted Oracle and Digital Alchemy. Shows that. Let's go. Rusted Oracle, unzip. Right here, we run it. 𝗙𝗟𝗟𝗟𝗪 process, wet hands. Okay, again. My god. Brings this. grep HTB, nothing. I'll trace that. Okay, Corwin well. I don't think that it's this easy. Oh, yeah, let's sleep for the next centuries, I guess. Okay, let's patch that. Binza this. So we go to main. We're inside main right here. And machine decoding sequence. I see. Here's a sleep. Yeah, I don't want it. So patch, convert to knob. Up something. So we click that. Patch, convert to knob. This has a rand right here. I think the rest is fine. So let's save it. Pepe right here. So we have Pepe, modex Pepe, and we run it. What was it? Corwin Well. Boom. And as we can see, the only thing here was to patch the sleep, yes. And we got the flag this way with the Corwin Well as our input. And let's head to the last challenge, which is Digital Alchemy. The Digital Alchemy. Zip that. CD. @ltrace 𝗪𝗘𝗟𝗟𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪 Guess. Initialize the Athanor. The Athanor glows brightly, revealing a secret, and we get nothing. Strings. Yes. Of course. Grep HTB. Nothing. ltrace. We see something here. Something here. This here. But no signs of HTB. Okay. Change the time. So we're inside main. Let's see what we have here. We have this. Let's call it encrypted. fopen, it opens ltrace, fseek, ftl, seek, malloc. Okay. If you don't know what fseek and ftl do, you can actually do this one fseek, and it tells you what it does. Pause the video and see it here. Same for man ftl. Yeah, enough here. Okay, then it allocates 3 and reads to that, reads from lead.txt. Okay, and then it compares the first 8 bytes with mtrl lead, what we have right here actually. So it's already fixed, and then it does bullshit. Takes 2, 3, 4, 5, 7, 8. So it starts from this, from the comma. Okay. Okay, so right here it shifts 8, then extends x18. Then it's probably a debugging shit, so better to patch that. Ready? That's always branch. And right here we have this, which is like a key, I guess. strlen of this, so this is the length. Then for I in length it does encryption, probably. Again, didn't I branch that out? Okay, and then compares the encrypted that much. Then it allocates 0x28, and right here loads 8, and then mem sets 8. Mem copy is probably the decrypted flag. And then it does some extra amazing stuff. And writes everything in gold.txt. Okay, the first thing I notice here is you have memset 8, but before that you have malloc. Let's just change that. Where is it? Change, not change type. I think it's E, edit line. But what? Okay, right here. So instead of X, ooh, rather ooh, edit line. And instead of 0x8, let's do 28. Okay, so now it has the same size with malloc above. And okay. Save Pepe, not Pepe. W. Okay, ls, so we have W, modx W, and run W. And then got gold.txt. Total gibberish, okay. Understandable, have a nice day. Sudo C, let's go again and see what happens. It reads from lid.txt as we said. Right here we have yellow int 32, int 32. Then we have unsigned int 32. Okay. What is probably doing all this crap is that right here we have int 32, which is signed. That means the range is a lot smaller than an unsigned. You can search that. Signed there, max value. So we see that this is actually this. It's 2 to 31 minus 1, and unsigned int max value, we see that is bigger than that, almost being double its size. So my guess is that this happens because when it shift lefts stuff here, it probably goes to numbers that are bigger, so they're translated to negative due to being signed right here. So I guess what we have to do is change int 32 to unsigned. So we're right here where it starts to load stuff. Yes, it does this, it does that. GX, SX, does reads the content of the register or effective address as a word or byte. Sign extends the SX. And 6 word or byte. Oh, yeah, okay. Sign extends. So I guess we don't want that. Don't want them to be signed. We want them to be unsigned. So I guess Okay, let's just don't do that. Don't. I guess this is like patching all these commands right here. I think this might be it. So go and change this after mtl red. So let's just remove that. Patch, nope. Save content. And okay. That was it, I guess. This looks like a good flag to me. This challenge, actually, what I saw right now is that it had two flows. The one was right here after malloc, before the mem set. Right here, it had 8. Let's just try and see what happened if we left it as 8. But let's go again back. Right here, disassembly, and edit. We leave this as 8. 8. Save. Yeah. So we actually get only 7 bytes because mcopy reserves that space for us. 7 bytes and the null byte. So the first flow was that. We just changed that to 28, or I guess something bigger could also work. 88. Save. Oh, okay. Let's just leave it with that. Patch, edit. Just leave it 28. Seems good. Let's don't play with a heap and get the flag. And the other thing that we should pay attention to was the junk translation, let's say the junk decryption that happened because of the signed and the unsigned values of the bytes that were deobfuscating right here. So yeah, these were the challenges, guys. And I hope you learned something from the video and enjoyed the challenges. If you did so, leave a like and subscribe to the channel to support me. And have fun. See you in the next video. Bye.